Greetings, welcome to my channel. This is question 2 chemistry part. You must expect this kind of a question on Monday. Most probably it will be also question 2 there. Now remember, you need to know the definitions of an element, a pure substance, a compound, homogeneous mixture, heterogeneous mixture. So this question is all about that. Then let me look at this question. Now we have 4 different substances, W, X, Y, and Z are represented in the table below. Actually, W, X, Y, and Z, all of them, they are represented in the table. There's a key that side. The key symbols for hydrogen, for lithium, nitrogen, and oxygen on that side. So the first question there, just look at the first question, which is the substance X, element or compound. You look at the table, is it element or compound? You must give the reason for the answer, and you also look at the key on the right hand side there. Okay, then 2.2, write down the letter of substance that represent the mixture. Then 2.3, write down the common name of substance Y. Then you draw the Lewis dot structure of substance Y. Identify the type of chemical bond between the atoms in substance W. Then from there, 2.6, hydrogen gas and nitrogen gas react to produce substance Y. So remember, for 2.3, you must be able to know the name of substance Y. So that will be the product. Write down the balanced chemical equation for the reaction that takes place. Is this synthetic or decomposition reaction? Must give the reason for the answer. The last question there, use the balanced chemical equation from 2.6.1 to prove that the law of conservation of mass in this reaction. Remember, the law of conservation of mass, it must be conserved if the left hand side is equal to the right hand side. But by doing that, you must be able to do what? To balance the equation. If the equation is not balanced, the law of conservation of mass is not going to be conserved. So the reactants, the mass of the reactants and also mass of the product must be equal. So this question is counting 15 marks. Okay, can we start with this one? Let me do this. We'll start to answer this question. You'll pause it and make it play. So start to answer this question by yourself before we can discuss the memo for that. Okay, so try to do this question by yourself. All right, then now let's look at the responses for that question. So 2.1 is an element. Let's look at 2.1. A substance X, so it's a nitrogen, so this is an element. So now define an element, which is this one. It consists of one kind of an atom. So consists of one kind of an atom. So that will be the 2.1. Okay, let's look at the reason. It consists of one type of atom only. So that's an element. Then what about 2.2? There is a mixture there. So which one do you think? For 2.2, it's a mixture. Okay, let's look at the answer there. 2.2, Z is a mixture. Let's look at the Z. So the substance Z is there. So Z, we have nitrogen, oxygen, hydrogen there. So that's a mixture. What type of a mixture of that one? Is it homogeneous mixture or heterogeneous mixture? Let's look at 2.3. Write down the common name of substance Y. So substance Y, can we try that substance Y? So we have nitrogen there, and hydrogen. So this nitrogen, it's surrounded by how many hydrogens? 1, 2, 3. So it's surrounded by 3 there. So can we try? Let's look at the answer for that one. Is ammonia, so which is NH3. So the common name for substance Y, NH3, is ammonia for substance Y. Draw Lewis structure for substance Y. The Lewis structure: nitrogen is group 5 in the periodic table. So how many valence? 5. 1, 2, 3, 4. Then we have 5. Together with 3 hydrogens. So this hydrogen, and that hydrogen. Okay. Or we can just say an N. 1, 2, 3, 4, 5. This hydrogen, this hydrogen. So meaning, so this is how we represent the structure of ammonia. Let's look at the way they responded to this question. Okay, they're using the cross and the dot to show an element. So this is 2 marks for that. Then now, identify the type of chemical bond between atoms in substance W. The type of chemical bond. Is it W? Is it ionic, covalent, metallic? So you need to know the ionic, metal plus non-metal plus non-metal covalent. It must be non-metal and non-metal. This one, metallic, metal and metal. So it's metallic bond. So you look at what type of bond is that one. You're going to choose from this. Okay. So now for W, lithium, metal, then nitrogen, non-metal. So you can see what type of bond will be formed by W. So it will be what type of a bond is ionic bonding. It's a transfer of electrons. Now an example, sodium chloride. So it will be sodium, then it's going to transfer an electron to become an ion. Chlorine, we need 1 ion so that we obey octet rule. Maximum of what? 8 electrons. So now the electrons are balanced. So this will be sodium plus chlorine. Then now we get sodium ion and then Cl. I'm sure about this one. So sodium will be transfer of electron. So then, because we talk about this ionic bond, transfer of electrons. So this is how we represent ionic bond. Okay, this one is ionic bonding example. So it's an example of ionic bonding. Then from there, now hydrogen gas and nitrogen gas react to produce substance Y. So write down the balance equation. So this will be your answer there. You can say N2 there as a gas, H2 there as a gas, then ammonia NH3 as a gas. Then you balance it. So this is how they balance. They put 3 there, they put 2 there. So this is how they balance it. Now what type of the reaction is this one? It must be synthesis reaction. The synthesis decomposition. If I'm having NH3, then to get H2 and N2, it must be decomposition. Decomposition reaction. So this one is the synthesis reaction. The smaller elements are combining to form a compound. So this one, the compound is broken down to form the elements. Okay, that's the difference between the two. So this one is the decomposition, this one is a synthesis reaction. So use a balance chemical equation from 2.6.1 to prove that the law of conservation of mass is conserved. So you count the mass of the left hand side and you compare to the right hand side. So you do left hand side, which is the reactants, left hand side, and then right hand side. Then you compare the two answers. So meaning left hand side is equal to right hand side. So the mass is conserved. This is how you're going to answer this question. You do them separately. You don't have to calculate the mass on the reactants this side. We're not going to do this. 14 times 2 plus 3 into 1 times 2 is equal to, you don't have to conclude, 2 into 14 plus 1 multiplied by 3, which is 34. This side is 34. So this is incorrect. You don't start by concluding. You calculate a left hand side separate, right hand side separate. Therefore, in a conclusion, you're going to say left hand side is equal to right hand side. The mass is conserved. Okay.